Cool, thanks.
All right. Yeah, so today's session is on unit testing. So I know, I mean, most of us, when we started coding, right, or we got introduced to coding, we didn't know anything about testing, right? I mean, I remember when I first started, there was this event that in Ghana we usually go to. It's called Dev Congress. So Dev Congress is like every tech community in Ghana, I mean, just coming together. So and you hear principal engineers, senior engineers talking about testing, why we should test and all that. And I mean, for us coming up, it was more of like, I mean, what are these people talking about? I mean, why should I write code to test my code? I mean, I know my code works, so why should I write an extra code to test it or to make sure it's working, right? But when you grow in your tech career, in your programming journey, you realize that there's a need for you to actually write tests, because at some point the code becomes so big that you can't remember everything, or you inherit someone's code, right? So you need to make sure that everything is working. You realize that some code base, once you touch something, multiple things are broken, right? I mean, currently I'm facing that on a job that I just do. I mean, there was no test written on the code base. There was basically nothing. I think 5 different engineers have worked on the code base, and they all use their own coding style. There's no architecture and stuff. So currently I have to do the refactoring, write all the tests, and make sure that, I mean, if I leave the code base, the next person that comes will be actually happy with the code base, right? And that's what testing is all about. All right, so we'll look at what is testing, what is unit testing, what is automated testing, why do we need to test, and what we can test, and some good practices when you're writing unit testing. And then we'll look at mocking in testing. And we'll also look at a practical example of basically how to mock a service and write a test and also generate the coverage. So what is testing? So this is more of like a general software engineering or software development definition. So software testing is evaluating the software against requirements gathered. So, you know, for those who came into programming from a CS background, or they've taken a course in software development cycle, right? I'm sure you've probably seen something like this, right? So when you are developing software, the first step is basically to gather your requirements. So basically talking to your users, gathering what they actually want, and then putting all those things in a document. So testing is basically you making sure that, okay, everything that you've gathered from the user, does your software match what they actually want? That's basically testing, right? And now looking into testing itself, there are different forms of testing, right? But looking into testing itself, we have something called the unit testing. So unit testing is now more of like code, right? So you are basically looking at a portion of the code that is it doing what it's supposed to do. So when you pick something like login, you ask yourself, I mean, is login actually doing what it is supposed to do? If you look at, excuse me, if you look at account creation, is account creation function or method doing the exact thing it is supposed to do, right? So that's basically a unit. So you are testing a unit, or you're checking, I mean, is your Flutter app actually saving the state? Is it behaving how it should, right? So those are basically just different units that you can test in your application. Now look at automated testing. So software automated testing is basically the process of evaluating and verifying software products or application does what it's supposed to do. So basically, again, now instead of basically doing the testing manually, so you're basically just automating the process. So you have a list of requirements, then you have a list of, so your requirement is basically your expected output, right? So what you expect, then you basically feed in what you have, then it will just match it to see whether, okay, is it the same? If it's not the same, it means that, I mean, the test has failed, or you didn't do exactly what's in the requirement. This is a quote by Robert. I think he's an author. He has a programming book, which you can check on Amazon. The Gentle Introduction of the Art of Programming. So now, why do we need to test, right? So, I mean, at a point, as I said, you realize that you actually need to write code, right? You need to write code to test your code. And but some may argue that it's not needed, because I mean that's another school of thought in the whole tech community, right? Some people believe that writing tests is actually not needed. It's a waste of time. But if you look at it, it's actually not a waste of time. So unit testing is actually very easy to write and run, because unlike other tests that you write, something like integration test, right, is very huge. So integration testing is basically a bunch of unit testing, like all together. So you're basically testing whether is everything working as a whole or as a family, or is the communication between this feature A and feature B, feature C, is it all synchronized, right? So that's basically integration testing. You're testing whether everything works hand in hand. So I mean, that's like a bigger picture, but unit testing is more of like a smaller picture, right? So you are testing each of the units, each of the components or the functions or the methods, right? So I mean, it's actually very easier to write than going like targeting the integration testing. And also even with Flutter, for example, we have widget testing or UI testing, right? And I remember some months ago, that's about 2 months ago, I was tasked to write a unit test for an app that we have. It's called Achieve. Achieve is an investment and savings app over here in Ghana. And I mean, it was very tedious because when we were developing the application, right, we didn't have the UI testing in mind. And for UI testing, for you to be able to identify the widgets in Flutter, either you call them by their value or their type or by key. So if you realize almost every Flutter widget has a key, right? So if you want to actually identify by the key, you have to add a key to every component that you actually want. You want to perform a hit test on, and then you then write a code. So this is actually, I mean, this was very tedious because the code base at that moment was so big. It was very big, and there were nested widgets, like widgets in another widget, and it was a whole lot of work. I think I wrote up to the homepage. So I wrote from the sign up process, the login process to the homepage. And I mean, the tech lead was like, look, this thing is going to take us so much time. So let us focus more on just the unit testing. And when we have time, or when we are actually not working on any active feature, we can then go back to the unit testing. Yeah, and that's it. And we're able to finish the unit testing, I mean, very fast. So it's very easy to write and run. Unit testing helps identify bugs at early stage. So as I said, Achieve is actually an investment application, right? So it's more of like a fintech. And the thing is, we are dealing with money, and you know, money is always a very sensitive like topic or thing. So we had this feature that's supposed to do something we call auto deduction, right? So you have a goal, right? So you say, this is my investment. I want to deposit X amount into this investment like every month or every week, right? And we automated the process that you can actually create something sort of like a cron job, like in the application. So I schedule that, okay, every month the 2nd of every month at 7 o'clock, deduct X amount from my bank and add it to my investment, right? So we had that in our application. But somewhere in the code, there was a function, right, that was in an infinite loop. We didn't know, because when we are testing, right, I mean, as a software engineer, anytime you're actually testing or you are, I mean, going through the app, you are usually go through something we call the sweet spot. So you already know what works. So you just go through that path and you realize that everything works nicely. But then when you give it to the clients will do something and something will break. Then that's why people start saying that it's working on my machine, right? I mean, yeah, it's working on your machine because you went through the sweet spot. You didn't test every use case, right? So that's what usually happens. And in our case, that was the same thing that happened. So, but luckily, before we released that feature, we wrote unit tests for that particular feature. Then that was when we identified the bug. And I mean, imagine you said about, let's say, like $1,000 should be deducted from your account like every second of the month, right? And this cron job or this schedule function is running in an infinite loop. It means that it's going to keep on deducting $1,000 from your account that day. So you have like your account runs into negative, because it just keep on trying until there's no money, and maybe the bank will start returning error that, I mean, there's no money in your account. And you know how people get very angry if something like that happens to them. So we were lucky that we were able to identify that bug very early and we fixed it. Another one too is it acts as better documentation. Yes, this is because sometimes when you look at some code base, it's actually very difficult for you to understand what is going on. You tend to find yourself, I mean, you're trying to understand, I mean, why is this function doing this? Or what does this function returns, right? I mean, if a test is written on that code base, you can still go into the test and just looking through the test, you will be able to identify that, oh, okay, this function, this is its work. This is what it will return. And even looking at the test cases that are on that particular test, you're like, oh, okay, if, so this function can never return now, this function is not supposed to be empty and all that, right? So you basically understand the code base better just from even reading the test. Another one is it gives you confidence to refactor your code. Yeah, so if you write a unit test for your code base, you can easily refactor. The reason I'm saying this is because, I mean, refactoring is actually something that's very tricky, because you can refactor and a lot of features will be broken, right? And the only way I'm able to identify that this feature A or feature B is broken is if you actually run your test that you've written against the refactoring that you've done. Then you realize, okay, login is broken, update profile is broken, right? Then you start to fix it. Because sometimes, especially if your code base is, let's say, written in the old version of Flutter, which is not null safety, and you decide to migrate to null safety, right? A whole lot of things change, right? And that tooling itself decide to add some sort of fixes to some of the things that it has identified in your code. But sometimes those fixes are actually not correct in a way. So if you don't have tests and you don't actually test those parts of the code, you won't catch that bug. You push your code to production, and I mean, your users will expose you, right? So it gives you confidence if you have to refactor your code. Now, what can we test in a unit? So you can test state variables. So state variables are basically variables that are outside the local scope. So these are like global variables that as we know it, right? So you can easily test them. You can test functions and variable calls. You can also test function arguments, making sure that the function is accepting the right arguments. You can also test function return. So you can also test whether the function is returning the right type. So if it is supposed to return an array or a list, it is actually returning that. It's not returning a map instead, or it's not returning a string instead, right? So you can basically test all those scenarios in your code base. And what are some good unit test practices? So one thing you have to know, that your unit test has to be fast, right? So integration test, one time integration test is big and it runs slowly because, again, it needs to test like the subunits and then test everything working together. So it takes more time than unit test. So unit test is just maybe testing your login. And for your login, all you have to do is just pass in your password and your email or whatever credentials you are using. And it's to mock the network call and return your response. It's as simple as that. It should be simple, yes. A unit test shouldn't be that's more complex than the code that you've even written, because if it is more complex, then it actually defines the reason for writing a unit test, because it's supposed to test the function that you've written. It's not supposed to be more complex than it, that you can't even understand what is going on there. And usually, if you don't write the function well, right? So I've seen in cases where people are passing context to functions that are not supposed to even take that context, right? They are basically mixing or merging their UI and their business logic together. If you do something like that, it will be always very difficult for you to write a test, because in that case, you need to mock either build context, or you need to find a way to pass in build context. And that's basically just complicates your entire test that you are writing. Yeah. Unit test should be deterministic. So you should be able to determine the edge cases, right? So you look at your login function, you ask yourself, what are the possible things that can go wrong with this function, right? One can be, it can time out. There's a network problem. After 60 seconds or 45 seconds, that's timeout. One is the user doesn't exist, but the user is trying to log in, right? So again, it will return an error of 44 or something, not found. The credentials can be wrong. So again, this time, let's say the email is correct, the password is wrong, so the error message is different, right? You can test against that. The email is wrong, the password is correct. I mean, again, you can test against that. So you need to actually put down all the edge cases, and you write the test against those cases. So basically, and again, you can't test against every scenario because you may not know every scenario. I mean, sometimes it's actually very huge, or the possibilities are very huge. So you just have to identify the ones that you can, right? And write the test case for them. It should be focused, yeah. So the unit test should be focused. So if you're writing a test, right, if it's for login, it should be about login. Don't add get profile in there, or don't add register user in there. I mean, it's that's not how it's done, right? So if a test is about login, everything in there should be about login. If it's about fetching data, it should only be about fetching data. Don't mix it with other test cases, maybe thinking, oh, let me just put it there so that I get the response for this one. I mean, it doesn't work like that. Separate every case, or every function should have its own test case, right? Then code repetition is okay in unit testing. Yeah. So there's one thing that most of people don't. I mean, in software engineering generally, you always been told that you shouldn't repeat your code, right? I mean, if it's something that you can create as a model and use over and over again, you should do that. But in unit testing, you actually encouraged to even duplicate the code if they need it, if you have the need, right? So, because sometimes when you create something like a global state, right, in your unit testing, it causes a lot of problem because again, it's like you are sharing like the same memory slots among different test cases. And this may alter the result that you want. So usually, I mean, every case you want to probably reinitialize that variable or that method. There's nothing wrong with that. Yeah. Test description should be easily understandable. Yes. So I think we'll look at that. So when you're writing a test, right, you need to give it a description, right? So that description for me, I mean, it can be long. I don't really care. The thing is, once I read it, I should be able to understand what that test is all about. So if it's more of like you're testing, let's say, a login, and the description is login with an email and password should work, or get profile. So fetch user data should return X, like, so basically you are passing in the class or the type that is supposed to return, right? I mean, when someone reads this, the person knows, okay, this test, this is what it's about. So it's about you fetching user data and it returning this. So if in the test case, it is rather returning, let's say it's supposed to return a map, then in the test case, it's returning now. There's something wrong somewhere, right? So, yeah. So I think this is, yeah. Then we look at mocking in testing. Now, mocking is a very interesting concept in testing, right? So there are some cases you don't want to actually make an actual network call, right? So you have your database, you have your API, then you have your mobile application, right? And you are writing a test. Now, you don't want to be actually making a network call, because again, if you're making a network call, it's going to make an actual call to the database and try to fetch an actual data, right? So in that case, you can actually mock the scenario or the client. So mocking the client is basically like you are mimicking its behavior. And the thing is, sometimes, I mean, usually our code depends on external dependencies, right? Either you're using a third-party library somewhere, or even like your own API is in there somewhere. And you don't want your test to rely so much on these external dependencies, because these dependencies can actually change the behavior of your test. So in that case, you create a mock of them and use that mock to rather mock. And the thing is, the mock actually behaves exactly like the actual client that you are testing for. So mocking is just a process of using. It's just a process used in unit testing when let me hide it. When the unit being tested has external dependency. The purpose of mocking is to isolate and focus on the code being tested, but not the behavior of the external dependencies. And in Flutter, the two common libraries that are used for mocking is either Mockito. I think Mockito, the concept was derived from the Android Mockito library. Yeah, then we have Mocktail, right? So I think we'll be using more of Mocktail in our example. So I mean, you can read more on these two libraries. They all do like very interesting things. Yeah. So the next part of this session is trying in code. So I have an application that I created it makes a network call to a dummy API and returns a bunch of data. So we are going to just write a test for the function to make sure that, okay, the function is actually doing what it is supposed to do, right? So let's get to it. You can find the code base, it's already on GitHub, so you can find it here, or you can just scan the QR code to get access to it. All right, so okay. Yeah. So we have this application. So first of all, just to explain the folder structure, I have a config folder that has my API. So the API link in there, and it's a singleton. Then I have my models. My models is basically or the data class, just a structure of what the data we are expecting like will look like. And then I have a folder called provider. So provider is basically just should I say a file or a class that so I'm using a Riverport as my state management. So basically just return the data that we need from our service or from our repository. And the repository itself is here. So this is what actually makes the network call. So it makes a network call, it returns a response, convert that response into a data class. Yeah, and then that data class is just consumed in the provider. Then we have the main. So the main is basically where everything is. So again, I mean, this is not the ideal file structure that I'll go for, but this is just to demo this concept. So we have, I mean, as usual, the main method, we have the app, the my app, which is which is creating the root of the tree. So we have a home page. Then you have a bunch of UI. So just what you see over here, an app bar, floating action button, and yeah, basically that's it. Want to find out why the data is not actually showing. Okay, a minute. I want to find out why that isn't written. I don't believe I've exhausted the number of times I can use. So what is this time? Yeah. Yeah, the API I'm using is basically dummy API, and I think it's supposed to have yeah, so we have some number of calls to make per day. So let me confirm the API the API key that I'm using. 279, 279. Okay. Yeah, so with what I'm doing here, I'm just passing in the API key. So I don't want to add the API key as a raw value in my code base, right? So I just want to inject it into the code base when I run the code. So that's what that's defined is all about. You can read more on it if this is your first time of hearing of it or seeing it. Yeah. So let me stop this. Wait again. All right, so I've explained the further structure and also, so I don't think I have to explain the code, but let me just explain the main thing, the repository, because that's what you'll be looking at. So I'm sure most of us are familiar with this.
I have a quick question. If you could just go back one to your setup. So the previous code you showed.
Where?
Where you were setting the API key.
Oh, okay.
Yeah, why does the release one need the toolargs and the profile mode not need that?
The release one need what?
The release mode, you have lines 27 to 29.
Okay.
And those are not, I would have expected either that those would also be after line 20 or in neither of them because it's in line 11 to 13.
Oh, yeah. So I just decided not to add it because I won't be running this, but again, if you'll be making use of this, you should always add it. So you can actually add different API calls or different API keys for each of them, so that when you don't, like in our case, you don't hit the limit. So yeah, it's basically the same thing, but just that when I run without this, if I run it in the profile mode, I'm probably going to get an error because again the key is not available.
Okay, thank you.
And again, to actually get the key, right? So you are passing the key. So to actually get the key, this is how you get the key. So it will come as a string. So you're getting this from the environment, and then you pass in the name. So the name is this API key here. It's again is the same thing you have over here. So it needs to match it, otherwise it won't be able to return the data. So I think our code base ran, and let me see. Okay, it's now working. Let me remove this breakpoint. Yeah, so basically this is what our app looks like. Is, as I said, it's not anything like very serious or very huge, right? It's just displaying a bunch of posts from the dummy API.
Now, hello, sorry, I have a question.
Okay.
So while you are at it, so on the launch JSON file, where you have your API keys definition there, so do you particularly push this file to GitHub or to any Git repository?
Okay, no. So if you look at my Git ignore, I think, yeah, I have it over here. So I'm not pushing it. So in this case, you have to, for something like GitHub, you have to set it up on GitHub. So something like adding like a secret, I think it's called secret key or something like that on GitHub. So it will act in this way. So in your GitHub actions, you can easily pass in a secret variable from your local GitHub, should I say local GitHub, from your GitHub to the action. So the action will be able to fetch this data from your GitHub. So in that case, you don't push this file on GitHub, because if you push this file on GitHub, basically you define the whole reason or logic of us hiding the key at the first place, because at the end of the day, again, you send the key out there. So the whole logic is you don't want anyone to know of this key, right? So that's why we are doing all this, and this is just, let's say, a basic security feature for your Flutter application, especially if you're dealing with keys and all that.
Ah, cool. Makes sense. And I'm really keen to know, so if you're working in a team, you are maybe 3 or 4 developers, and you all need to access this key. So if you place it in gitignore, how are other people going to access the same key, the same API keys?
Right, so now if they are supposed to use the same API key as me, then I'll have to find a different way of sharing this key with them, right? So it's more of how we share or we sync our API keys. For example, with where I work, we have system tool called Vault. So Vault is more of like you have to basically install it and you run it against our server. So it connects to our server and all our keys are on the server. So if you need any key, you need to get it from there to your local application, right? So I mean, it's just a way of us sharing our keys without disclosing it to like anyone. And again, as I said, I mean, it's a fintech application, so and money is very critical. So I mean, these are things that you don't want to just miss, because once someone gets into your system, you get access to your keys, I mean, basically you are gone. They will just keep on taking money out of your accounts. Yeah. So I mean, personally, that's how we do ours. Maybe your organization can also identify a way of you guys sharing keys secretly without like anyone actually knowing.
Cool,
And I
cool.
think
Thanks.
Vault is an open source application also. I'll get the name, and so yeah, but it's basically open source.
Okay, cool. Thanks.
Okay. Yeah, so now let's dig in. So I think I was explaining the repository. So repository basically we are making a get HTTP call to our API, and we are adding the headers. So the headers it contains the API key that we are supposed to pass to it. Then we are checking if it's successful. So if it's 200, then we basically decode the body. And then over here, we are basically passing the body in the data, the JSON data in the data field to a list. So, and basically a list of posts. Yeah, and over here we are basically returning it. So, which means that with what we've done here, our post can never return now. It will always return an empty array if there's no data, right? So, which means that in your front end, you can easily handle that. You can check if it's empty, then you show a UI that maybe there's no data, refresh, and all that. Yeah. So now let us head over to our test folder. So this where we'll be doing most of our stuff. So in writing unit test, you need to write it inside this folder. It will be created for you by default in Flutter. So you just have to head over to this folder and create a file. Again, I mean, almost every company have their own way of how they structure their test files. If your company doesn't have one, I mean, you can create it. Yeah. So in ours, so we usually have a folder for every test. So again, for let's say you have a folder called auth, and auth is going to contain the authentication. So more of like login user or a login test dot that with account, get password, and all that. Or we have a file in there called auth test dot that, and it has all the tests under authentication. So create account, login, forget password, what again? Should I say delete account? Yeah, sort of. Yeah, so everything will be in there. So by this, I'm just putting it directly in the test folder. So let's start writing our code. So the first thing you have to do is to basically mock the repository. Since over here, currently we are testing the repository, so I have to mock the repository. But before that, as I said, we'll be using certain library. So we'll be using let me get rid of this. So we'll be using Mockito for our mocking. So you can always check out its documentation. Let me quickly do that. Okay. Okay, so you can check out its documentation, right? So just to go over the documentation with you. So let's say to create a mock, let's say you have a class called cat, and cat has some things inside it. So basically, but can you see the browser screen? Because
Nope.
you can't see it. Oh, sorry. No, okay. Is it visible now?
Yeah, it is.
Okay, sorry about that. So as I said, we'll be using Mockito, and you can head over to pub.dev and search for Mockito. So going through the documentation, to create a mock, let's say you have a class called cat, and I mean cats, they have nine lives, and what do they like? They like food, and they also make a sound. So you have all this in your class, your cat class, right? Now you want to mock this class. So all you have to do is create a new class called mock cat, extends mock. So basically the mock is going to come from the Mockito library, and it's going to implement the class over here, the cat class. And then basically that's it. So that's just how to mock a class. It's as simple as that. So now in your code, now, you can then use the mock class, the mock cat class, as if it was this cat class that you are using. So basically, that's how to mock it. And to verify behaviors, there's some keywords that you can use the when. So we are saying that when, let's say, the cat class, or this class, right, the sound is called, then it should return what? So we are saying that what? It should return the sound, the meow sound. So then in your code, right, like let's say under your code, you can then do the verification to verify. So sorry about that. So you can then verify if the sound is called and the number of times it's been called. You can also verify if the sound return, right, is equal to what you are expecting. So if over here you are saying that it should return meow, and let's say in this case you are putting this over here, it doesn't match with this, therefore this test will not pass. We'll look at that into details, but basically this is how to use the Mockito library. The documentation is pretty straightforward, so yeah. So now let us look at that in our code. Okay, so I'm going to stop this. Right, so going back to the test file, so I have a file called post underscore test. So I want to mock the repository. So I'm going to have class mock post. I think this is about okay. So mock repository. Extend mock implements. So our class, so we have an abstract class in the main class. So I want to use the main class. So post repository implementation. Now I think I need to import this mock. So from the Mockito. So now we have this ready. Now in writing test, there's this tool. Say it's 4 methods. So there's this method called setup or setup, and so we have setup or we have tear down or then we have setup, then we have tear down. Now these 4 methods are basically used to set up your testing environment. So in case, let's say you need to do a setup before the test run. So let's say either you want to initialize some class somewhere, or you have to initialize a library somewhere before the tests start running, right? So you put them inside the setup or setup, right? So setup all basically is more of an array. So it sort of takes like multiple setups. Setup itself just takes like just one. Then, so the same as the tear down is more of like it has set it up, now it's breaking it down. So it has finished the testing. So when the testing is done, it's more of like disposing or canceling like all those things that you've basically initiated or clearing the memory. Yeah. So, I mean, you can choose to set it up. So to use it, something like this setup. Just have set up all. Let's return a function. So now I have this over here. So I can say date mock tools, mock. Then in my setup, I can do this mock repository is equal to mock. All right. So in this case, I'm assuming that I'm going to have multiple test cases that are all making use of this, and I want to basically share the same initialization like between like all my test cases, right? Then for the tear down, so you can just set it to now, or if you have a clear method somewhere or dispose method somewhere, you can just call it here. So currently, this method is not nullable. So again, if I have to use this, then I have to make this nullable for it to work out. Yeah, but I won't go this method. I just want to do the implementation as how it is. So Now, for our first test case, so looking at the repository, the method here is to get post, right? So, sorry. So I'm going to have test. So test is basically coming from the test library itself. So the Flutter test library, and you can locate this in your YAML file. When you go to dev dependency, you can see it over here. So it's basically just coming from here, right? So, and it's expecting a description. So this is what I was talking about, that it needs to be descriptive enough for anyone who reads it to know, okay, this is what the test is about, right? So this is I'm just going to put something here, and yeah, and so basically, I mean, this is it. Now will then move on to our Mockito, so then use it to make a fake HTTP call to the method, the get post service method, and then we'll mock a response again, and then we'll then match the responses. So explain. So when let me refer to the docs. Okay. So when we have, yes, I think first I need to initialize my mock class. So mock then say mock post dots this. Then so I want the answer should be this an invocation. I don't need the invocation, so I'm just going to represent with underscore. And over here, so this returns a future list, right? So future dot value. And over here, sorry. So inside the array, right? So we need to add different posts because it's expecting a list of posts. So this, the list now we have posts. So like this should contain different posts. So this post is coming from, again, my models, right? It's coming from the models. But I don't want to do it this way. Let's see. Yeah, what I can do over here is can say posts dot post dot from JSON. So basically I want to pass in JSON and looking at, so I think the documentation gives us, so the dummy API, the documentation gives us an idea of how the data looks like. So models, post preview. So this is how it looks like. And let me correct this bunch of mistakes. So the ID, can put anything here. It's supposed to be a string. The text also supposed to be a string. The image, again, supposed to be a string. Likes is a number, so an integer. So let me say 12. Tags is an array. So an array of string. So I'm going to do this. Publish date is a string. So I can say date time, but now let's ISO date. Then owner is an object of the user class. All right, so I think we have a user class in our post. Yeah, so this. So over here, I say user from JSON again. Before that, let me terminate this statement and bring in some spacing. So this user, let me now look at a user preview. So user preview, yeah. So there's it. So this is how it's supposed to look like. And I'll bring it in again. So interesting enough, there's actually another library. I think it's called Faker. Yeah, so you can use Faker to actually generate like data for your test. So like instead of doing all this, you can just use Faker to generate like actual values, like actual names and IDs and all that you need for your test. Okay, and add this thing. So let's. All right, so I have a post and it has the nested class called user inside it. So now with this, I don't really need to pass it this way. You can pass in a post. So I want to just use it like multiple times. All right, so now this is what I have. So I'm saying that if I make, when I make a network call to this endpoint, this is supposed to return. So this the return is the answer it's supposed to give me. So basically, I'm mocking the response. So the response should be an array containing 4 posts, right? So basically, this is 4, 1, 2, 3, 4. So now, just under this, can now make the call itself. So post is so await mock get service. Then to add a sync sample again. So now we have this. So over here I can say, so the actual is 4. So post dot main. I'm expecting 4. I can also say I'm expecting this. Expecting post should be a type, right? And the type is a list. So a list of posts. So over here, I'm doing more of like a type checking, right? What again can I check for? I mean, even before this, I can check if it's empty, right? So if it's empty is false, because we have data here 1, 2, 3, 4. So these are basically some expected edge cases that I've like come up with. So now to run our test, you can click on this run, or you can go to this section and then run the test from here. So let's see if our test will pass. Okay, it didn't pass. We have what? User is not a subtype of this cast. This okay. So we have an issue here from this. Oh, okay. Sorry about that. I think I need to have user separately. Is passing in the class, or yeah, the class user instead of the map containing the user data. So you can see this is of type user. So I can pass in this dot to JSON. Let me run the test again. So as you can see, 1 out of 1 test has passed 100%. So it has basically it has passed. And so I mean, generally, you can decide to add more tests or test for particular things. For example, maybe you want to test if tag contains data, if what again? Yeah, if a post has been liked, and like all those things that anything that you basically feel like it's an edge case that you want to test for your particular function, you can easily do that when you're writing your test. So basically this is how to do it. And there are a bunch of this. You can always refer to the documentation for them. I mean, they're actually a lot. Yeah. So now once we want to generate a code coverage for what we've done, right? So I don't know if I can do it here. Coverage. I haven't tried it here before. Okay, let me just do it through my terminal. So I'm using FVM. So I have multiple versions of Flutter on my machine because of some of the projects I work on. Like they are way before Flutter moved to nav 17. It's pretty difficult to migrate the code base. So yeah. So to basically add check for the coverage. So coverage is basically you checking so the code base, right? Like this code that we've written for, let's say, the repository, you are basically checking like what have you covered, or what part of the code have you written test for? That's basically the coverage or the code coverage, right? If you hear some of this like talks on test, they'll tell you that you should target 80 and above, 90 and above, and all that. So we'll look at what all those things mean. So I'm going to run this command for it to generate the coverage. Okay. So now if you look into the folder structure, there's a new folder here called coverage, right? And it contains this file, this file. And if you're using Mac OS, you need to install this software or utility, right? So you can do that in your build. I think I've added some description to the README file. So if you are using a MacBook, you need to install this. So you need to run this to get the utility on your machine. And now, so we have the code coverage information, but now we want to convert it into HTML so that we can be able to view it, right? So to do that, you basically run this command. So gen HTML, so we want to generate HTML, then the folder called coverage, then the file, then open, then you want to the output should be again inside this folder, a folder called HTML. So let us look at that. So when I paste, so when I run this command, you can see it has generated a new folder called HTML, right? So this is basically just HTML code, and you can easily open it in your browser. Yeah. So now you can see this is the code coverage report, and in total we have 44 lines, and the hit is just 25. So it means that we have a whole lot of other lines to basically test for. It says that function is 0, but I think it's a mistake with my setup. So I mean, we have one function in there, or one method in there. And if you look over here, it says well, the coverage is 58.1%. So I mean, this is like way below what is usually expected, right? So that's why it's in red. If it were to be, let's say 80, 90 and above, it will be green. Yeah, so like showing that I mean, you've actually done well in the code coverage report. So now looking at this table, we have all the repositories in our code, right? So as you can see, I have the config file. So the config.dat file is here, and it says that we don't have any test for it. So it's basically like 0, right? Then going back, we have our models. So you can see we have our models is like 83%. So this means that we have coverage for 83% of the models. It is 6, but we've covered for 5. Yeah. So I mean, when you open it, you can actually see the particular line of code that you didn't write, like you didn't cover. So as you can see, it's showing that this line, this particular line, I haven't like written a test to cover it. That's why it's in orange, I think, here. And for the rest, you can see there's a test case for them. So use their color. Then going back to the top. So we have repositories again, repositories to since that we have our 8 and we haven't, it's not saying the test coverage for them. So yeah. So we haven't written coverage for this and all these things. Yeah. So basically, I mean, that was it. So this basically just shows you a summary of how your test coverage is. I know there's in certain code bases, if you're writing test and you push the test, there are services that run your test against some of these reports, and if the test that you're actually pushing right to the code base is not, let's say, above 90, it will reject it, right? And if it's above 90, then it will merge it into the main test branch. So yeah, basically that's it. There's still more to do in, I mean, testing generally, because testing is like a very huge topic in software engineering. And as I said, there are like different types of tests that you can write, but the fastest that you actually want to do, or depending on your time, right, will probably unit testing. I mean, where I work, as I said, we didn't have testing in mind when we started, right? So along the way, we decided, okay, things are breaking too frequently, so let us start writing tests to guard against that. So then what we did was we went back to do something we call chore. So we had a branch called chores, right? So the chore is if I'm working on, let's say, a feature called, let's say, make payments, right? Then after working on that feature, I have to also write the test against that feature before I push my code. So, and for the old features that don't have test, when you are free, so we are four in a team, two people are busy, you are not busy, you are not really on any tasks. You can just take any of the features and write a test for it, right? So at the end of the day, I think in a month we're able to write tests for the old features that we didn't write tests for, and also for the new ones, we're able to add like new test cases for them. Yeah, I think that really helped reduce the bugs that we're facing in production, because sometimes you develop the thing, it's working on your machine perfectly, right? As I said, you go through the sweet spot. Then at the end of the day, on a client's machine or a user's phone, it's behaving strangely. It's because the user has clicked on something that you didn't click on. So because of that, I mean, it's basically just exposing the bug that is underlining there. So yeah, so this will bring me to the end of my my session, basically. If you have any question, you can just let me know, so I will address it. Yeah. If there are any questions, please ask.
All right, thank you so much. That was a nice session. I really learned a lot. I use a different package to write tests, and it's good to know that you're using Mocktail, something that I can check out later on. So do we have questions from the audience at least? Do you have questions for Etornam based on his presentation or any testing related question? I know we are past time by 20 more minutes, but we are thanking you for the patience. Yes, Moses?
Helen, can you hear me?
Yes.
Thank you, Etornam, for the amazing discussion. Just one question about your code. Why are you returning a JSON object on the owner parameter in the test?
Okay. Test. Let's go to yes. Test. Yeah. So
that line.
Yes. So this is actually expecting a JSON, right? The reason why I'm actually doing this is because if you look at this, I'm saying that I want from JSON, and it's expecting JSON. If you look deeper into the model class itself, right? This user has something. It's what? It also has this to JSON. It doesn't expect a class. For example, like the API doesn't know of a class called user. All it knows of is going to return you a JSON. If you make an HTTP call to that particular endpoint using, let's say, Postman, or I think I have standard client here. Yeah, so if you make an API response to it, you realize that every data that it returns is JSON. Therefore, you need to match the data that is actually returning you. Otherwise, you saw that there was an error that I had. It was complaining that it was expecting a JSON, and I was passing a type that was not JSON. That was not a map, basically. So let me quickly show that. This. Anyway, this standard client, it's sort of like Postman. You can use it to basically make like test endpoints in your VS Code without having to leave VS Code to open another application. So it's called, the header is called this. And the key is this. Yeah, so can you see the data that it's returning?
Yeah.
So it's returning a JSON. So I can see the owner here. It's a JSON. Therefore, my response needs to match it. So basically that's what I'm doing.
Okay, thank you.
You're welcome.
Thanks, Moses. We heard Okello. Please proceed with your question.
Hello, Etornam.
Hey.
Nice presentation. So I had a question, mostly preferably it was like a way to proceed. So it is a preference one. So there's two ways for writing tests. So there's that one whereby you write tests before you have written your code base, and there's this way. So which probably do you prefer most?
Okay, yeah. So there's I think it's TDD and BDD, right? It's a whole bunch of terminologies. So for me, I usually write my tests after I write the function, right? So I'm usually testing against the fact that the function that I wrote is actually working, or it's actually doing what it is supposed to do, right? So I have a bunch of edge cases. So I then write the function. So if it's login, I then write the whole login function or method. Then I go and write a test for it. So now inside the test, I have a bunch of edge cases, right? So as I said, maybe the user doesn't exist, even like the user is blocked, right? Because sometimes, I mean, for financial applications, you can block a user. So like all those sorts of errors, right? So basically, I list them down and write test against it. Then I run it and see if, I mean, it basically works. So in the future, anytime I'm about to deploy a code to production, I run all the tests again, just to make sure that, I mean, everything is working as how it is. So for me personally, I usually write my test after I write the function. Again, in some companies, right? For example, I work in a company that for them, you have to write the test first before you write the function. But the thing that I realize about that is sometimes it takes so much time, because again, you start to spend so much time on the test than the actual function that you need to write. And I mean, there's advantage and disadvantage for all these two scenarios, but usually depends on the company culture or you as a developer, the culture that you've adopted. Okay, this is what I'm going to do. This is how I'm going to do my stuff. Yeah. But for me personally, I write it after I write the function.
Thank you.
All right, thanks. And besides that, I have one last question based on the test. So how do you, besides mocking the API and stuff, so do you have a specific framework to use to do like the end-to-end tests of the user interface?
Yeah, so for user interface, right? So what I did previously, it was so cumbersome, right? So there's this testing framework called Cucumber. It's very popular, right? So there's a version for it in Flutter called Gherkin. So Flutter Gherkin, I think you can check it out it's on PAP. Yeah. So it's more of like you automating the UI flow. So you basically state the design, the language. So this language has to be in, I think, in a Cucumber. So you can say like the scenarios, like, okay, when a user, let's say when a user is on the home, on a login page, like get the email field, enter this text in the email field, get the password field, enter this text in the password field, get the login button, tap on the login button. So then the next scenario will be they should be on the home page or something. So all those scenarios, you need to actually write it, right? So it's like in English, it has its own, should I say, syntax, sort of syntax. Some are given, so given that I start with this, when, then, add, and all those things, right? So you write it in this document, and then you have to call this in. So using the Flutter instrumentation test package. So this works with that, and like they work hand in hand. So you basically do that integration, and then you run this. So it will run against, it will generate a whole bunch of files for you, and it run against these scenarios. So, and the thing is, that particular method, it's so bulky. As I said, you need to like first write the code to do the actual test, right? So you identifying the email field, the password field, the button like widget. So that's the test that you are writing, and you also write this document, this definition document for Cucumber for you to understand what it is testing for. So I mean that's for UI testing. So I'm not really happy with UI testing. I think I saw a post on Twitter. Someone wrote a new framework for UI testing in Flutter, and I'm yet to check it out. So check it out during this weekend. So if it's much easier than what I did then, I'll probably scrape that off and use his. Because when I was using that, honestly, I wasn't happy until like I was done with the whole thing, because it was so clumsy.
Yeah, asking that because the Flutter plugin, that's what I've been using so far, but it's like having lots of things, like there's a lot to write. So that's the thing.
Exactly.
Yeah.
You write lots of things.
Yeah, anyway, thank you for that. Do we have any further questions from the audience? If not, we really thank you for your patience. And because we are past time, but by 30 more minutes, and that's a lot for your Saturday evening. So thank you so much for joining, and thank you so much, Etornam, for this presentation. So we'll share with you the GitHub repository and the slides after the session, and also the recording if you'd just like to listen in to the recording sometime later on. And yeah, that's it. And one last announcement is we'll have our second last meetup of the year in November. We'll share the dates with you, and then our last meetup, which is should be in December, will be not so much technical, but probably someone to talk about opportunities in Flutter or anything to do with that. So thank you so much for joining, and really appreciate your presence today. And someone is saying thank you for organizing. Yeah, thank you so much for joining. If you are not part of our WhatsApp group or Flutter Kisumu Twitter account, feel free to follow us with this handle. Let me just write it. At Flutter Kisumu. So that's where you'll see the updates of our next meetups. So thank you so much and have a great evening.